Hello students, and welcome to this lesson on the properties of quadrilaterals. Our objective today is that we will summarize properties of quadrilaterals using journal notes and graphic organizers. Now, an important note about today's lesson. All of this page that you're seeing in front of you needs to be on a right-hand side of your journal. I'm just going to leaf through and show you what we're going to do today. So this needs to be on a right-hand page because what I want is for this properties of quadrilaterals chart to be on a left-hand side of a page, and then this parallelograms chart to be on the other side, so to be on that right side. So when you open up those pages together, you'll have your nice chart of your properties, and then your Venn diagram side by side. So again, this title page needs to be on a right-hand side so that these two pages will open up together. Now make sure that you have enough space and that you've cut out your charts already and your Venn diagram already so that we can go ahead and put this all together. Alright, so jumping back into our lesson, let's go ahead and define a quadrilateral. And that's pretty easy. You guys already know what this is. It's just a four-sided polygon. And you guys have heard about different types of polygons. You've heard about a quadrilateral, a pentagon, a heptagon, and so on and so forth. So this isn't really anything new. However, what we're going to do today is we're going to work on actually classifying these quadrilaterals and making sure that we know exactly what differentiates them. Alright, so just take a moment and see if you can identify the differences between these four figures. So this first figure, we notice that we have parallel lines here and here, and we also notice that these segments are going to be congruent. So this is actually our parallelogram. And some of the features of a parallelogram are that they have two pairs of parallel lines, and also that the pairs are congruent, so it has pairs of congruent sides. So our next figure, we notice, has all those same things, right? It has two pairs of parallel sides, and those pairs of parallel sides are also congruent, but this appears to be different, right? These two shapes definitely are different, and we know that this is called a rectangle. And the main difference here between these two shapes is that a rectangle is going to have four right angles. So that's an additional feature of rectangles. So rectangles are just parallelograms that also have four right angles. Well, that's interesting. So a rectangle seems to be a type of parallelogram, which itself is a type of quadrilateral or four-sided figure. Now, what about this next figure? Well, it doesn't appear to have any parallel lines, and that's actually going to be true. It doesn't have any parallel lines, and it really has no distinct features other than the fact that it has four sides. And typically we call this, I would normally call it a general quadrilateral, but you might also call it a trapezium, which I don't really like using that because sometimes you can confuse it for a trapezoid, but trapezium is just another way to say a general quadrilateral. And the one thing, the distinct feature of general quadrilaterals is that they're going to have all angles will add to 360. So interior angles Alright, and finally we have our favorite. We have the ever-popular trapezoid. So the trapezoid, it doesn't have two pairs of congruent lines. It only has one pair of congruent lines, and those lines don't even have to be congruent. So a trapezoid has only one pair. Sorry, these aren't congruent, these are parallel. My bad. These are parallel lines, one pair of parallel lines. So we see that there are definitely distinct, different quadrilaterals, and that it's important for us to be able to categorize them because they'll have different properties. We'll get into even the diagonals of these being important as well. So let's go ahead and fill out our chart. So make sure that on the next page, so this was a right-hand page, and on the next page, so on the back of this page, you're going to want to have your polygon chart glued in, or your quadrilateral chart glued in. It'll look a little bit like this. So go ahead and glue that in, and then we'll continue on. Alright, so let's just go through each of these, and we've got a little diagram up here at the top, and that's going to help us out filling out this chart. So let's first look at these first two categories. So a figure with four sides. Well, all quadrilaterals have four sides, right? So all of these figures here, all these different types of quadrilaterals will meet that requirement. All right, and now we say that all angles add to 360 degrees. Well, we also learned on our last page that our general quadrilateral, right, it has interior angles that add to 360 degrees. So again, all quadrilaterals will meet that requirement. Now, the next one is that all angles are congruent. So if all four angles are going to be congruent, right, and we know that they all have to add to 360 degrees, then I could say that 360 is equal to 4x, because they're all congruent, therefore they're all the same length, and they have to add up to 360 degrees. So x plus x plus x plus x is going to be equal to 4x. So we can say that x must equal 90 degrees if that's going to be true. So all angles being congruent means that all of those angles in a quadrilateral will be 90 degrees. So let's think about our shapes that have angles that are 90 degrees. All right, so let's look. So a parallelogram. Well, it doesn't look like all of them have to be congruent, right? You have these two angles here, which are definitely different from each other. So we know that that is actually not going to be true. So it won't be true for a parallelogram. However, in a rectangle, we know that that's a requirement, and is that all of the angles are 90 degrees. So we can go ahead and put an X here. And then we look down the line, it looks like a square will also meet that requirement. A rhombus doesn't have to, right? All it has to have is that its sides are congruent. And it looks like those are the only shapes which will require that. So our next item is going to be both pairs of opposite angles are congruent. Well, if we look at our parallelogram here, that appears to be true. My pairs of opposite sides are congruent. So we know that that is a requirement of parallelograms. Rectangles, well, all four are still going to be congruent, so we can go ahead and put an X here. What about for our rhombus? Well, it looks like that's also a requirement of a rhombus. And then additionally, that's going to be a requirement of our square. All right, so those four figures they have the opposite sides that are congruent. I'm sorry, the opposite angles that are congruent. All right, what about a kite? Well, a kite, you might want it to be true, but it looks like that's true for this pair, but not for this other pair, the angle B and angle A. So it's not going to be true for a kite. A trapezoid, we have our opposite sides being congruent. No, that's not going to be true. And then our isosceles trapezoid, or non-isosceles trapezoid, definitely not. So those are our only four that meet that requirement. All right, so these next few I'm going to go through a little bit quicker. So one pair of opposite angles are congruent. So only one pair of the opposite angles are congruent. All right, so we look down our line, and it looks like, well, we already determined that that was true for the kite, right? So only one pair of opposite angles are congruent, and it looks like there's no other figure that meets that requirement. All right, great. So now all sides being congruent. Well, that is definitely a rhombus, right? That's the definition of a rhombus, is that all four sides are congruent. And then it looks like that will also be for a square. All right, so now we move on, and so we say both pairs of opposite sides are congruent. Well, that's true for parallelograms, rectangles, rhombus, and square. So both pairs of opposite sides are congruent in those four shapes. All right, and then both pairs of opposite sides are parallel. Again, that's a parallelogram for you. And then a rectangle, and then a rhombus, and also a square. All right, and only one pair of opposite sides is parallel. Well, we know that that's a requirement of a trapezoid, so let's go ahead and mark our trapezoids. The diagonals are perpendicular, so this is where it gets a little bit harder. So we're going to see that the diagonals are going to be perpendicular in a rhombus, and we can see that in the diagram up above. And we're going to find out that a square is just a special type of rhombus, therefore a square will also meet that requirement. What we're noticing is that an important part about the diagonals being congruent is the fact that these adjacent sides are congruent. So we'll also see that in a kite, its diagonals will be perpendicular as well. And that should make sense because our area formula for rhombus in a kite that we learned was about the diagonals, and they always form that right angle. All right, finally, we have that our diagonals bisect the angles at the vertex, and that will be a property of our rhombus and our square. And then our diagonals bisect each other, and we'll see that that is a property of all of our parallelogram family. So parallelograms, rectangles, rhombus, and square. And then also we'll see that a kite, we have one of the angles will be bisected, or one pair of the angles will be bisected. So as you can see, these are a lot of different types of shapes with a lot of different types of properties. And it's best to not try and memorize something like this, right? So we want to think about a way where this will be more natural for us, right? Something which won't necessarily be an act of memory for us to perform. And then I've made a mistake here. The diagonals are going to be perpendicular. That's this line right here. And then this line here is actually that our diagonals are going to be congruent. And so our diagonals being congruent, that's going to be true of a rectangle and then also of a square. All right, so let's go ahead and see if we can organize this information in a little bit of a different way. So let's go ahead and look at our chart. All right, so for our superset, right, in the box, we're going to draw just a general quadrilateral. And the property of general quadrilaterals is that all angles, or sorry, interior angles rather, add to 360 degrees, and then my other property is that they have four sides. So that's all figures. Then we have parallelograms, and parallelograms are an awesome family of figures because there are so many different types of parallelograms. So we have this parallelogram here, and a parallelogram is going to have a whole bunch of different properties to it. You have your parallel sides here, and one property of them is that they're going to be opposite sides being congruent. And I'm going to start using some shorthand here, so I'm going to use the congruency symbol. So my opposite sides are going to be congruent. My opposite angles are going to be congruent. My opposite sides are parallel. And again, I'm going to use some shorthand. Remember, this is our symbol for parallel. We also see that the consecutive or adjacent angles, so we're talking about the angles that are, if you're looking at them here and here, this is something that should be pretty straightforward to us from our parallel lines theorems, right, with our transversals. But we know that those angles, so those adjacent angles, are supplementary. And then finally, we know that the diagonals bisect each other. All right, and then from there, we know that, so this is an interesting fact, a rhombus meets all of the requirements of being a parallelogram, and then the additional fact that it has 4 congruent sides. So a rhombus is just a parallelogram that has 4 congruent sides as well. And we see here that the diagonals will now bisect the angles. The diagonals will also be perpendicular. And I'm using this shorthand for perpendicular. And then additionally, we have our 4 congruent sides. All right, and then we have our rectangle, which is really just a parallelogram that has 4 congruent angles. And then we'll see that the diagonals here are congruent. Finally, we have our square, which the square exists as both a rectangle and a rhombus, so it has all the powers of both. So the square is the most specific type of parallelogram. It has 4 congruent sides, it has 4 congruent angles, and it meets all of the requirements of every shape. So it has all features. So if you can imagine rhombus and rectangle being 2 separate entities, the square would be what happens when you combine them. All right, now let's talk about kites. So a kite is going to have this property of having 1 pair of bisected angles and 2 pairs of adjacent congruent sides. And what's really important to remember about kites and rhombuses is that a rhombus has all 4 sides being congruent and a kite does not. So if you have a kite and you're like, oh yeah, this is a kite, and you have all 4 sides being congruent, you don't have a kite, you have a rhombus at that point. So a kite can only exist when it has 2 pairs of adjacent congruent sides that are also not all congruent to each other. So then we have our general trapezoids, right? And a general trapezoid could look like this, it could look like this, or you can have the isosceles trapezoid where you have 2 congruent sides and those 2 parallel sides. So an isosceles trapezoid is going to have a median. Well, they all have a median. So all trapezoids have a median, which we discussed last week. And then an isosceles trapezoid is further going to have 2 congruent sides. And of course, all trapezoids have 1 pair of parallel sides. So again, this is a lot of information. I know it might seem a little mundane to some of you, but this is a really important category of figures that we use all the time, especially in construction. So it's important to know the differences between these different objects. All right, so your reflection today is to answer these following questions as true or false. A square is also a rectangle is also a square, a trapezoid is also a parallelogram, and a rectangle is also a parallelogram. So answer those true or false, then you will get started on your homework and activity. Thank you and have a wonderful day. Goodbye.